Good morning. How exciting. I can say that one of the, in eight years ago when my daughter was diagnosed, and I told this story a lot, but you go on the website and you typed in APS Type 1 and there was nothing there, and here we are today, how exciting this is. So I want to tell you a little bit about just our experience, which will lead in very nicely to Dr. Lionakis's and Lucie's discussion. I always like to draw on Pablo because Pablo's comment is the only thing APSers all have in common is the will to survive. And that's so true because all of us have a different story as to our experiences here. So let me tell you a little bit about Gabby. From infancy, we dealt with, as some of you may have had, the unknown rash. That would come and go. We had a lot of fun with that one. Never understanding exactly where this thing was coming from. Actually went to the Children's Hospital of Philadelphia and was completely undiagnosed. I worked for Colgate at the time, so at that point, her teeth were erupting and I saw decalcification. And I knew about it because of my background in dental and couldn't quite figure out, but again, they said high fevers. She did have some high fevers when she was younger, so this was decalcification brought on by high fevers. In early childhood, she had her first seizure, and that was around the age of 6, and again, attributed to a high fever, so we were wondering what exactly, why at the age of 6 would she suddenly start getting febrile seizures. So we did the full neurological workups, which some of you have done, the epilepsy workups, the stress, like trying to keep a 6-year-old up all night so that they were stressed, the octopus head. I remember all those fun tests. The neurologist came back and said, we found nothing, thank you very much. So then we moved on, never fully knowing, what was, all these weird symptoms that we just couldn't figure out. And then in early adolescence, she struggled with exercise, complained of pain in the side. She would, and I used to say to her, you're out of shape, you got to work harder. That was typical father of a family of 6 kids. And then side stitches, started to develop memory loss issues or memory issues and more seizures. The last seizure, which was, we were going to be sent home again, so this was our 4th or 5th one, and we had a physician who was head of infectious disease, if you can imagine, came down to see us, and the resident kind of went through the list and said, oh, and her calcium's 5, but it's probably an off reading. And the guy, our good friend said, why don't you check it again? And that led to, 6 days in pediatric ICU. So the good part is we had a diagnosis. And I think the most important thing, that we learned in this process is most importantly, always trust your gut. Look at your labs, even if you don't understand them. We do that a lot. What exactly is that, and why is it low? So I'm sure you all deal with that and experience that on a regular basis. Obviously, you're here because of your child, and you'd be surprised what you can accomplish. I mean, here we are, sitting here 8 years after diagnosis with a foundation, raising money, and this kind of awareness. Pretty exciting stuff. So again, ours was much different than everybody else's, and I think it's going to draw into Dr. Lionakis' discussion where he can really start to see that there's a lot of changes and dynamics to what we deal with on a day-to-day basis. Thanks.
Okay. Thanks, Jennifer and Irene, for putting this, I think, great venue together. So as Todd alluded, we as physicians have failed multiple times, at least in a country like the United States, where when you look into the PubMed and publications, you really will be hard-pressed to find a case report or two. So I'm sure, and we'll hear from our Scandinavian colleagues, it's a different story in a country where this is more common. And when somebody presents with something that is alarming, or even with prenatal diagnosis, things get streamlined a little bit better. So I think we have 2 major challenges that I'm going to try to touch upon over the next 5 years. So as our previous speaker nicely showed, there are 3 classic triad manifestations that provide the hallmark for a clinical diagnosis that then raises the suspicion, if a good clinician is there and thinks about it, to send for genetic testing. And it's a unique susceptibility to a single infection, which is a fungal infection, and two very severe and life-threatening endocrinopathies, as you've seen here. Now, the question that arises is, in this side of the world, is how good clinicians are is when they see 2 out of these 3, or even 3 out of these 3, to say, oh, that's got to be APS. And I must say that we are better than we were 10 or 20 years ago, but we've seen many patients in our cohort study over the last 2 years that they had the classic triad, and they were not put together for many, many years. So I think one major point is, in this country at least, in this side of the world, where APS is not that common, or it's not as common, I would say, as it's thought to be, we need better awareness, and that's something that we can do. But I'm going to step back for a minute and ask, I think, a key question that, again, arose through seeing patient after patient at the NIH the last 2 years, which is, are these clinical criteria any good? And let me ask the question that will answer that, which is, how many patients really presented their 2 first manifestations being among the classic triad? Because that's a key question to try to understand whether we are able, even you have an aware physician, to really make the diagnosis. So the first presentation in 31% of the patients is not among the 3 classic triad ones. The second manifestation, half the time, is not among the 3. And the third sequential presentation, again, half of the time is not one of the 3. So if we put this together, 70% of our patients do not present with their 2 initial symptoms being among the 3 classic triad. And the question is, what are those? We heard urticaria and urticaria-like rashes, and that's a common one. Malabsorption is the most common in our cohort here. But also patients present with hepatitis early on, or hypothyroidism early on, or alopecia, and nail dystrophy and/or enamel hypoplasia. And these are 3, I think, illustrative examples. So this is a first patient who had candidiasis and malabsorption at the first 2 years, and it only took 7 or 8 more years to present in an ER with an adrenal crisis and hypoparathyroidism. The second patient presented with candida and malabsorption, and keratitis is the third one, and it took another 20 years for the second classic triad manifestation to occur. And the third one presented with 2 things that we don't think very commonly about APS, which is alopecia and nail dystrophy early on, and then another 7, 8 years passed for the 3 classic manifestations to happen. So not only we're missing critical opportunities to prevent deadly, potentially, manifestations, such as patients presenting in the ER with a blood pressure of 0 or calcium of 3, but I think, as you'll hear, I think the next 2 days through research, perhaps opportunities to prevent the manifestation of these altogether. Perhaps a patient who presents with candida at age 1, that should be the only manifestation they get. Now, another last example I have here that again manifests that these criteria need to be revised is a girl that presented at age of 5 with hypoparathyroidism, the next year with hepatitis, the next year with pneumonitis, and now 5 years after that, the other 2 symptoms or manifestations are missing. So by these criteria, she doesn't have APS, but she has a very well-defined genetic homozygous mutation. So this is a small summary of what we have seen through the last 2 years at NIH in over 40 patients now. And of course, the first 3, which is the triad, are very, very common. But as you can see here highlighted, there is a slew of other manifestations that, although less common, that doesn't mean that they present later. And also, as you can see here, they reach frequencies in the 40s and the 50s and the 60s. It's quite not uncommon. So what we need is we need better awareness when actually the classic triad develops in the 30% of the patients, to not wait for another 5 years to make the diagnosis. But we also need to better understand the full scope of the syndrome and develop better criteria for triggering genetic testing. And more importantly, we need to continue doing translational research from the bench to the bedside and back to the bench to develop reliable screening tools novel genetic platforms, and I'll touch upon, I think, what was mentioned in the previous talk about the diversity and the phenotypic variation tomorrow in my talk, as well as, more importantly, better preventive and therapeutic interventions for the entire spectrum of the syndrome. And as you'll see over the next 2 days, one drug does not work for everything, and one simple answer is not available for all. But there are answers for most of the things, if not all, and that's what I think the message is. So with that, I would like to pass to Lucie.
Thank you. So I thought I'd start off with, say, a definition of genetic counseling. I took this from the National Society of Genetic Counselors. So genetic counseling is the process of helping people understand and adapt to the medical, psychological, and familial implications of genetic contributions to disease. So what does that mean in practical terms? So typically in a genetic counseling session, I would meet with a family for an hour or so to review different aspects. If it's a first visit and we don't have a diagnosis yet, it would be to interpret family and medical histories to assess the chance of occurrence or reoccurrence of a genetic condition. Once we have a diagnosis, that's confirmed genetically. It makes it very straightforward. We do a lot of education about the inheritance itself. We arrange genetic testing. We discuss the management once a diagnosis is established. We talk about prevention. We talk about resources, such as family support groups like this one. And it's wonderful to see so many people participating in this first event. We also talk about research opportunities if they're available. So really the goal of genetic counseling is to promote informed choices and adaptation to the risk of to the genetic condition. So we've heard previously from Dr. Harrington, the gene is the AIR gene, which is an autoimmune regulator. It makes a protein called the autoimmune regulator protein, and it's inherited in an autosomal recessive manner. So when we're doing genetic testing, what exactly are we looking for? So I just want to give you a brief review of some basic genetic concepts. So let me see if that works. Okay. So if we are to look in any cell of our body, we find our genetic information, and it's packaged into structures called chromosomes. We have 46 chromosomes. If we then stretch out the chromosomes, you see the DNA here, and I'm sure you've seen pictures of DNA before. A gene is a section of DNA, and we have about 25,000 genes. And everyone has 2 copies of the AIR gene. One we inherit from our mom, and one we inherit from our father. If you look at the structure of the DNA, it's made up of 4 chemical bases: adenine, thymine, guanine, and cytosine, and we shorten that for A, T, G, and C. And you have to have the right letters in the right order to make a functional protein. So when we do genetic testing, what we're doing is actually reading the gene to see if there's any spelling mistakes within that gene, and we call that a mutation, and that causes the protein not to work properly within the body. So I did a quick review to see where testing is available. There's 8 places within the United States that I had identified. There might be many more, but that's just on brief review. And there's many other countries that actually offer testing for this condition. I just wanted to spend a little bit of time talking to you about recessive inheritance. So in this picture, I mentioned to you we each have 2 copies of this gene, one we get from our mom and one from our dad. In this scenario, we have, where's my arrow? There it goes. Okay, so we have a dad who has 2 copies of the gene, 1 copy in blue that contains a mutation, and the other copy does not. So they would be considered a carrier. The same is true for the mom. She carries one copy of the gene that doesn't work and one that does work. Carriers are completely healthy. They have no symptoms. And we all carry about 8 genes that don't work properly of those 25,000. It's only when 2 people who carry a mutation in the same gene have children together, then you have a 1 in 4 possibility of having a child with that genetic condition. So if we go through the scenarios, if the mom and dad both pass on the gene that doesn't work, the child would have the condition, so in this case, APS1. If mom, oh, sorry, I can't find that. Or mom and if dad passes on the gene that doesn't work, mom passes on the one that works, or vice versa, the 2 children here in these here would be carriers just like their mom and their dad and be healthy. And then the last one, if they both pass on the gene that doesn't work, or that does work, pardon me, the child would be healthy and not have APS. And so when a family who are carriers, parents that are carriers have a child, each time they have a child, there's a 25% chance of having a child with APS1. And it can happen both in boys and girls, as you probably know, and there is genetic variation whether you inherit that, both copies, as illustrated by the zebra picture that Dr. Harrington showed us. We have about 25,000 genes, so there's other genes at play that may modify the APS1 gene. So that's all I had to talk about today, and I would welcome any questions and invite the panel back up.